Hello guys, my name is Rami Khan, and in this video I'm going to explain the mechanism of esterification and some examples. So what is esterification? Esterification reaction is a reaction in which a carboxylic acid is reacted with an alcohol to form an ester, and this reaction takes place in presence of an acid. So esterification is a reaction in which a carboxylic acid, this is a carboxylic acid, and it is reacted with an alcohol. Suppose this is our alcohol R dash and these two are reacted in presence of an acid to form an ester, R C double bond O R dash. This is ester. This is our carboxylic acid Ca. Let me write carboxylic acid by Ca, and this is our alcohol. So actually this alcohol can be a phenol. This carboxylic acid can also be its derivatives like acyl halide or ester or anhydride. Okay, so the reaction goes like this. As a trick, I can just represent this reaction like this. So this is not a good marker. So this water goes like this, and OR, which is the alkoxy group, is attached to this carbonyl carbon atom. So this is our product. These two R's can be same or different. If they are same, then it is easy. Or not, they can be same or different. Okay, so accordingly we can form different esters. So let me write the mechanism of this reaction first, and then let me give some examples. Okay, so first of all, this carboxylic acid, this oxygen has a lone pair of electron, two lone pairs of electron, and this accepts this H plus ion, or it donates its electron to H plus ion as acting as actually base. Giving out electrons to H plus ion is the base. So we will form like this. This oxygen will carry a positive charge because it gives out its electrons, and one lone pair of electron is left. This is our OH, right? So from this a pi bond will be broken, and these two electrons will go to oxygen as lone pair of electron, because oxygen carrying a positive charge is not stable. So this goes like this: R C OH. This has two lone pair of electron now, and oxygen has, again, this oxygen has two lone pair of electron, and this carbon will carry a positive charge, right? So from here, let me write that again here: R C OH. Here it is again OH, and this carbon is a carbocation now. So to this carbocation, our alcohol, this is our alcohol R dash OH, and this oxygen contains a lone pair of two lone pairs of electron again. So this oxygen will attack this carbocation, as here it is acting as nucleophile, right? So we will get R C, here it is OH, this again OH, this is our O, and here it is R dash, this is H, a lone pair of electron is left only, and this oxygen will carry a positive charge, right? So here from this intermediate, this H plus ion will go out. This plus ion, this H plus ion will be taken out from this intermediate by water. This hydrogen will be abstracted as again base. So in some books, this base is acted by the conjugate base of this, right? Conjugate base, yes, conjugate base. If we take H2SO4, then this H plus ion will come out from H2SO4 dot, therefore its conjugate base will be HSO4, something like that. And if I take HCl here, then conjugate base will be Cl minus ion. This water can be replaced by Cl minus ion or H2SO4 minus, HSO4 minus. Okay, but let me represent this base by water. So this water, oxygen abstracts this hydrogen, and these two electrons will go to oxygen, back to this oxygen as lone pair of electron. So we will get this intermediate. This is our R dash, this is R dash, right? So now this is our lone pair of electron. Let me write this again here, RCOH. Here two lone pairs of electron are there, and let me write this OR dash in this place, and here it is OH, right? So this H2O and the H plus becomes H3O plus. So this is our H3O plus. This oxygen abstracts this hydrogen again as base. So this becomes RCOH2 plus, right? OH, one hydrogen is abstracted from this hydronium ion to become OH2 plus, and this is our OR dash, this is our OH. Now this bond is broken and water molecule will be removed, right? So we will get, so this carbon will carry a positive charge. From this oxygen, two electrons will come here to stabilize this carbocation. So we will get R, C, this will be our OH plus lone pair, and this is our OR dash. So water goes out like this. Now this oxygen of water will abstract this hydrogen as base, again as base, B minus is base, and this two electron will go back to this oxygen atom as lone pair of electrons. So we will get our final product, this RC double bond O and OR dash. This is our ester, right? This is our ester. Okay, this is the mechanism for esterification. Now let me give some examples of esterification. Let me rough this part so that I can write some examples. This blue color of marker is difficult to remove. It's difficult, but the black color is easier to rough. Okay, now let me write some examples of esterification reaction. So examples. First example is CH3 C double bond O OH. This is our carboxylic acid, ethanoic acid or acetic acid, and it is reacted with CH3 CH2OH, for example, in presence of an acid. So water goes out like this, and we will get CH3C double bond O, and this ethoxide ion will be attached to this carbonyl carbon atom. So we will get this ester plus water, right? So this is our ethanoic acid, this is our ethanol, and this is the alkyl group attached to this oxygen is ethyl. So its IUPAC nomenclature is ethanoate, right? Or it can be written like this, ethyl acetate also. Okay, so another example I can give, this CH3C double bond O OH. Again I am taking acetic acid, and if it is reacted with phenol in presence of an acid, so we will get water will be removed like this, and this phenoxide ion will be attached to this carbonyl carbon atom. So we will get CH3C double bond O and phenoxide ion, right? This is called phenyl ethanoate, right? So now let me give another example, which is specially called trans-esterification. So I have already told you that we can take derivatives of carboxylic acid instead of this carboxylic acid. So I am taking this as the derivative. This is ester actually. This is ester. This is called methyl ethanoate. This is called methyl ethanoate, right? And this can be reacted with an alcohol which must contain 2 or more carbon atoms, because this alkyl group which is attached to oxygen contains only 1 carbon atom. So we must take an alcohol which contains more than 1 carbon atom. If we take methanol here, we will get this ester. No reaction will take place. We will get the same ester. So I am taking this alcohol. This is our ethanol. And this bond will be broken. Methoxy group will combine with hydrogen to form methanol, and this ethoxide group will be attached to this carbonyl carbon atom. So this also takes place in presence of an acid, and product is ethoxy group will be attached to this carbonyl carbon atom, right? So we will get this product. Plus here we obtained water as the byproduct, but here we will get methanol as the byproduct. This is our methanol. Now let me write this name. This is ethyl, which is attached to oxygen. So IUPAC nomenclature of this is called ethyl ethanoate, right? So these two esters are different. So and this alcohol is also different from this alcohol. This is our methanol. Now this is called trans-esterification. This is an example of trans-esterification. So in trans-esterification, we take an ester in place of carboxylic acid, and this ester is reacted with an alcohol which contains a different number of carbon atoms as to this alkyl group, which is attached to this oxygen, right? So that we obtain a different ester. So this is called trans esterification. An example which is given in NCERT, let me write that example. In the fourth example, this is our benzoic acid, and to this, in its ortho position, I am attaching OH, right? This is called salicylic acid, 2-hydroxy benzoic acid. Okay, salicylic acid, and this is reacted with this compound, right? This is called acetic anhydride or ethanoic anhydride, and this is taken in place of carboxylic acid. I have changed the position actually. This is acetic anhydride and it is a derivative of carboxylic acid. This is acetic anhydride, and this is acting the role of alcohol here, right? The role of alcohol is played by this salicylic acid. In fact, this is the alcoholic part, right? So the product will be hydrogen from this part and okay, this whole portion will be removed, and this will be CH3COOH acetic acid will be formed as a byproduct, and to this oxygen this acyl group will be attached. This is acylation actually, acylation of alcohol or phenol. Acylation of alcohol or phenol is called esterification actually. Okay, so we will get this product. This is our COOH, and to this oxygen this acyl group will be attached. This is the product, and as a byproduct we will obtain ethanoic acid. Okay, these are some examples of what esterification reaction, and this is called, I think, aspirin, right? This is called aspirin. Okay, for this video let me stop here, and if you like this video please share to your friends, and if you are new to the channel please subscribe to my channel and also press the notification button so that I get motivation to make more videos for you and your friends. Thank you.